So what are the different types of internet connectivity that we have? Well, the first one we see here is the single-homed. You can think of the single-homed solution as your home internet connectivity that you have. Typically, you have that single connection using a single link, using a single router up to a single ISP. That's single-homed. Now, you might have remote offices or branch offices, remote workers, using this type of single-homed connectivity, whereby if internet connectivity went away, it went down, the link got cut, the ISP had a problem right here, that's fine. It's not detrimental to the organization. It's not going to affect it that bad. So when we're dealing with this type of single home solution, there is no redundancy. There is no high availability. If something goes down, any one of these single points of failures, the router, the link, or the ISP, there's no connectivity for the amount of time that it is down. So you have to weigh those options. You might want to add a little bit of resiliency to the mix here by going with the dual home solution, whereby you have that single router in the mix, and this single router that we have at the customer site has two links up to the ISP. And in this particular case, if one of the links goes down, well, the other link can handle the load and still enable the connectivity that's necessary. However, we might want to take this dual home solution just a small step further and implement two routers in that customer site. That way there, if one router fails, well, there's still the other router available. So as you can see, we can layer on additional routers, additional links, so that way there we are maximizing our availability. We are maximizing our resiliency, or in this particular case, by adding the redundancy. However, a lot of organizations have mission-critical resources that need to be up all the time. And the last thing you want is to have a single ISP fail on you. So if this was the enterprise organization and the ISP, had a failure, now the customers that we have can no longer access our web-enabled resources, our front end, as you might say, whereby they can purchase the products that we are trying to sell. So that will definitely hurt us. What we might want to do, if this is a requirement of ours to have availability all the time, is to have connections up to two different ISPs. So in this example here, we could have one router that is the exit point out of the organization that is going to ISP1 and ISP2, and this is known as a multi-homed solution. We could also double it up. Let's add in another router to the mix here, so that way there we are limiting some of those single points of failure. So we no longer have just one router going to both ISP1 and 2. We have two separate routers, one going to ISP1, one going to ISP2 in this multi-home scenario, giving us that extra level of redundancy, resiliency that we need to ensure that we're always available. However, in those highly critical, we can never, ever, ever be down type of scenarios, right? We want to be up 100% of the time. We could ensure that we have redundant links from our routers up to our ISPs, but we will make sure that in this scenario, that if one of the links goes down, then we still have connectivity up to those respective ISPs. But we might even want to take this dual multi-home scenario even further, and as you can see, now we have 4 routers. Each of these routers are connected to a single link, or they might even be connected to what? Multiple links, if it's required within our organization to ensure that we always have connectivity up to the internet. So our customers, no matter where they are, if there's a failure in one of these ISPs, that's all right. Traffic can go this way if it must, but if that goes down, traffic can go this way. Now, in these types of scenarios, we're using dual multi-homed or multi-home types of scenarios, you're really going to want to be using BGP. That's where we're going to see the use of BGP. Why? Because with BGP, we can now start to manipulate the routing policies, manipulate the attributes that are being utilized in order to control the a path selection of outbound internet traffic and inbound internet traffic. Whereas in these types of scenarios here, where we're dealing with our single homed or our dual homed, we can really get away, as long as we're only using a single router, we can really get away with simply using static routes. Static route pointing to us from the ISP, static default route from us pointing back to the ISP. We can accomplish our goal with static routes. But as soon as we start getting into these more complex types of scenarios that we see here with multi-homed and dual multi-homed, you'll see that BGP definitely makes our lives easier as an administrator, but more importantly, we are going to get that level of resiliency and redundancy that we need. We'll further explore BGP in an upcoming discussion.